Okay, good evening. Welcome to
GreatMath90.
GreatMath90. So this is a problem I saw watching a video of a lecture that was on MoMath in New York. Remember MoMath?
Yeah.
It was this lecture was given by Po-Shen Lo, who's a mathematician at Carnegie Mellon.
Yeah.
And he had a neat little problem. He said you start out. He had it with a bucket of pennies, but we just happen to have this bag of dice from Family Math Night laying around, so I just used dice. So you have 6 buckets.
Yep.
And each bucket has 1 dice in it.
Yep.
It's supposed to be 1 penny.
Yep.
Okay. And he says, here's the rule about a game you can play. You can pick up any one of the dice, any of these 5, a dice in any one of these 5 buckets, and take it away,
Yep.
and replace it with 2 dice in the next bucket over this way.
Yep.
But this dice, if you touch this one, it just disappears.
Yeah.
Okay? So any one of these, any dice that's in any one of these buckets, you can pick up, take it away,
Yep.
and it becomes 2 dice over in the next one.
Okay.
All right?
Yeah.
So the game is to try to play with this and create the most dice you can create on the board. Okay?
If you touch any in this column, it disappears.
Yeah, if you touch any dice that are ever in this bucket, they all disappear. The
So-
other dice, and it disappears.
So maybe what you want to do here is you want to not shift any dice over into this column.
Well, it's okay to shift them into here.
Yeah.
Like you can touch this one and it becomes 2 over here.
Yeah.
But once they're in here, you don't want to touch them.
So if you touch any, they just disappear. So you don't want to remove any.
Yeah.
So what you could do is you could start by maybe, let's see, you could take this one, get 2, and then
No, it becomes 2. And
comes 2.
there you go.
So then this would be 1 goes, let's see. So we have, and this, each of these becomes 2.
Yeah.
So you get 6 of these in this column.
Okay.
So then,
Maybe instead of stacking, we should just have you write the numbers.
yeah,
So how many are in there now?
there's 7. So now each of these is becoming 2. So each of these will become 2. So you shift all of these over, you're going to get 14 more. So this will be 15 in here.
Okay.
And then, so there's 15. And then they'll all go to be 31 because 13 times 2 is 30 plus 1 is 31. And then 31 times 2 is 62 plus 1 is 63. So I got 63 is my most.
Okay. What was the pattern? Like what? If we continued these numbers backwards, what was the number that was here?
So I was here, so I think it would have been, let's see, 3 here.
3 there. And what was the number there? So that's
1,
interesting.
3, 7, 15, 31, 63. So I see a pattern here. So 1 plus 1 is 2, 3 plus 1 is 4, 7 plus 1 is 8, 15 plus 1 is 16, 31 plus 1 is 32, and 32. And 63 plus 1 is 64.
Huh.
So these numbers plus 1 all equal the powers of 2.
Oh, that's interesting.
Hmm.
How do you think we could figure out if 63 was the most? I mean, maybe you just made 63 and that was that. How could we figure out if that was the most, do you think? We don't have to. I'm just curious if we were going to go back and do it. How do you think, what would you have to do to figure out if 63 was the most?
Well, you could analyze the pattern. So you could try moving the 2 over here and then leaving 1 and moving them all over. You could try a bunch of scenarios.
Okay.
Yeah.
That's interesting.
Did they find any higher?
No, you know what? 63 is the right answer. They didn't find any. Where do you think is the most valuable place for a dice, one of the dice to be to produce the most dice? Which box is the most valuable box?
Well, it seems like maybe any of these 5.
Okay.
No, maybe. Oh, maybe it might be at this box because you have them. I don't have the most dice in this box, and then it went to there.
Oh, I see. So that you think this box is pretty valuable because that's where all the dice. That's where all the dice ended up. I see. Well, that's interesting. Okay, hey, that's really good work. That's a pretty cool problem.
Yeah.
All right, good job.